This question is about the relationship between gravitational force and the separation between two objects. So you can do this, you can approach this a number of different ways. The crucial thing is that you realize that F is inversely proportional to R squared. So you can then express that as F equals a constant over R squared. And this constant in this situation is will be G, the gravitational field strength, the gravitational field constant, M, the mass of usually the larger mass, which would be the sun, and then the mass of Mars in this question. It doesn't actually matter what the bodies are. That doesn't matter so much. Then that K value, these are all constants, so they're going to be constant no matter what. So in the first example, we've got that at one distance, you've got that F equals the force is given as F at this separation of 2.1 times 10 to the 11, and then what is it when it's a bit further away? So it's going to be less. So it's got to be A or B, and then we can do the calculation to see which it is. Now, the way this works, F, if I call that R1 squared equals K, and that K value, this GMM, must also equal to the second force, and when they're furthest apart, which I'll call F2, because it's further apart, just to distinguish it, and this is R2. And then we're asked for what is F2 in terms of these. So F2, if I rearrange for F2, then I get F2 is F multiplied by the ratio of the squares of the separations. Okay, so R1 is the smaller value, so 2.1 times 10 to the 11, divide all squared, divided by 2.5 times 10 to the 11 all squared, not forgetting the F. So you do that, one of the answers will be if you forget to square it, and the other answer will be the correct answer out of A or B. So 2.1, let's just check, 2.1 times 10 to the 11 all squared, divided by 2.5 times 10 to the 11 all squared. And we get that F is 0.71. So this F2 is 0.71 F.